1,651. That's the total number of investigations performed on the International Space Station since it first started operations through Expeditions 38-39. Researchers from more than 83 countries have relied on the unique facility that is the space station to help with their scientific discoveries, contributing in countless ways to the health and safety of life on Earth and in space. The collaboration between the station crew and ground controllers at Marshall's Payload Operations Integration Center, Europe, and Japan resulted in more than 300 investigations on station this year alone, and record-breaking hours of science conducted by the crews each week. Over the course of a year, we interviewed several researchers about their investigations to learn why and how they're conducting research on the International Space Station. Now, while we can't get to everyone in the next 30 minutes, you'll hear from some of the scientists about their investigations. But first, let's hear from Ellen Stofan, NASA's chief scientist, to find out why this orbiting laboratory is so valuable.
We had experiments that had included a 3D printer to start testing. Can we eventually get to a point where we can produce parts for the International Space Station on the International Space Station rather than bringing them for Earth? We took up rodents for the first time since the shuttle days, and we're going to be using these rodents as model systems to better understand the effects of microgravity on the human system, and using those mice potentially for drug development. Things that happen to the human body in space, like bone density loss and muscle wasting, are things that happen to us as we age. So can we use the fact that these processes occur very rapidly in space to develop new treatments that benefit us right here on Earth? So direct benefits to the world of science, direct benefits to human health, that's the kind of research we do every day up on the International Space Station.
As the chief scientist, though, I'm sure you want to see more. There's more that can be done. What do you tell folks about that?
You know, that's why this extension to 2024 was so important to me, because as a researcher, you really want to be able to say, can I come up with a theory, come up with an experiment, send it up to the ISS, see what my results are, and tweak my experiment, go further, go to the next step. And that's what that 10-year extension of the ISS has given us. And so the rodent research I was talking about, we're just beginning. We're going to have rodents, model system, fruit fly experiments going up on the ISS that are really going to help us start addressing questions on how do we send humans on that long journey to Mars, that 8-month journey to Mars, 8 months back, time on the Martian surface. That's a lot of time out of the Earth's protective environment that protects us from space radiation. So we have a lot of research to do on the International Space Station over the next 10 years to really get ready for that journey to Mars, and we're excited about it.
And the space station has also given researchers who may not have ever gotten anything in microgravity, they've given them an opportunity. It's easier now to get on the space station, right?
It is easier. We're really working at NASA to try to make the ISS a researcher-friendly environment, and through our efforts as well as CASIS, which is the organization that runs our national laboratory on the space station, we're trying to get new partners, not just our traditional research crowd, but can we get pharmaceutical companies? Can we get companies that do materials research? Can they start seeing the benefits of doing microgravity research? So we really want to exploit not just the scientific potential of the International Space Station, but its potential commercial uses.
What do you tell folks who say, the space station, that didn't mean anything to me?
You know, I really try to focus on this fact that when we're working off the Earth, we're working for the Earth. From the RapidSCAD instrument that we just put up to help measure ocean winds, which is going to be able to allow us to do better weather forecasting, better understanding of the climate, that's something that affects us directly right here on Earth. From things like, again, bone density loss. Okay, that's what happens to us as we age. Osteoporosis. We're looking into developing new treatments based on what we're doing on the space station. So while we're not right here on Earth, everything we do is to benefit the Earth. And those technologies that we develop are being done right here on Earth. We send them up to space and test them, and there's huge numbers of spin-offs that come from that. The benefits of the ISS, to me, are just endless. The one-year mission is something that we've really been looking forward to in the Human Research Program, because there are a lot of things that happened, again, to the human body in space, from, again, the muscle wasting, bone density loss, the rise in intracranial pressure that affects vision, changes in the immune system. Our crews mostly go up for 6 months. So, okay, what happens after 6 months? Do those effects plateau? Do they lessen? Do they get worse? Those are things we really want to know. And so by having the 2 astronauts up there for a year, Russian astronaut, US astronaut, it's a great opportunity to really push that envelope and what we understand about the effects of microgravity, and again, critical for this much longer trip to Mars. The other exciting aspect, of course, of the 1-year mission is that Scott Kelly, who's going up for a year, happens to have a twin brother, Mark Kelly, former astronaut, who's here on the ground. And so not only are we going to be doing the 1-year studies of the long duration effects, we're also doing a number of twin studies to say, okay, we've got one in space and one on the ground, same genetics, what can we learn from that? Really exciting.
So let's take a look at some of those investigations, from growing veggies to studying how flames behave in microgravity, and what we've learned by observing our planet from more than 200 miles up.
It's the first continuous HD downlink from the ISS. I mean, we've had other cameras up there before, but they've sort of been spotty coverage. This is the first one that's on all the time. It's actually 4 cameras, 4 commercial off-the-shelf HD cameras, in an enclosure that's built to test temperature control. And the cameras, the main purpose of the HDEV project is not to take Earth imagery. That's just a very cool added bonus of it. The real purpose is to test how long these cameras can survive in the space environment before they degrade so much through things like cosmic ray hits that they're not usable anymore. So with the 4 cameras, there's one pointed in the ram direction, the forward velocity vector of the ISS. There's 2 facing aft and 1 facing nadir, looking right down on the Earth. And the way the system is currently set up right now, the video feeds cycle through all 4 cameras. But there's 2 educational opportunities that are coming up that we're working with student groups in Germany, University of Bonn, through the German Space Agency, DLR, and also the University of Houston Clear Lake has a group of students also that will be looking at the camera both to collect data for specific areas, but also to monitor the primary purpose of the experiment, see how the cameras are degrading over time. And so those programs are just getting spun up. But in the meantime, yeah, the HDEV is returning spectacular HD views of the Earth.
The first one is an area called Los Glaciares. It's a national park in Argentina. It's right on the Argentine-Chilean border. And it's particularly significant because it's one of the few areas where there are glaciers, specifically a glacier called Perito Moreno, which is actually growing. Most of the glaciers in that area, in that particular glaciation field there, are shrinking. But Perito Moreno is growing, and there's a lot of research there trying to figure out exactly what's going on, why this one particular area, as opposed to the other areas, are increasing. Glaciation is one of those things that has it's a fingerprint of what the current climate is and how things may be trending. So glaciation studies around the world are very important. The next one is Lake Titicaca. This particular image is on the northwestern shore of Titicaca, right at the border between Peru and Bolivia. Titicaca is a very important area. It's a huge local fishery. It's very important to the local area because of the tourism business there. And it also is an indicator of the health of the planet. As the water level rises and falls, and as the water quality increases and decreases, it's a good indicator of what's going on generally in the environment. The next image that we have is the Upper Nile in Sudan. This is a late afternoon shot. You can see there's a pink glow cast across the landscape from the setting sun there. The Nile, of course, is critical for agriculture in the area. Most of the population in the desert environments live along riverbanks. The Nile, of course, is the focus of the population in that area. What you see here is a set of villages that are interspersed with agriculture along the banks of the Nile. The Nile itself is the source both of the water and the fertilization for those fields. The people in those areas depend on the agriculture that's in their local area to survive. And modifications to the environment, the Nile has been modified over the last 50 years or so to have some significant effect on the ability of the people to conduct their agricultural activities.
The hardware consists of an LED lid with lighting underneath it, with a bellows system and a skeleton that holds that all together. We have root maps with seeds inside of them, and it's an accordion type system that will raise as the plants grow. And the lighting system is only the light that is necessary for plants to live, and it's a 24/7 cycle, so there is no nighttime, so it grows very quickly and we turn the crops very quickly. It's unique in a way that it's very interactive to the astronauts. They can touch it, feel it, have the goodness. There's been plant science up there, but it's all been enclosed and very controlled environment. This environment is outside. It's very, very interactive to the astronauts. We are very interested in the environmental control and life support systems. With this plant technology, ISS with 0G, we're able to take and assess what the plants do in the grow, and what we're trying to do is capture the humidity, condensation, and recycle it back into the environmental control systems. So in this effort to resource utilize as much as possible. Now, it's critical to do this at 0G, because if we're going to do long duration space, Moon, Mars, this has to be done, and we have to recover and take those resources as far as they can.
People have been studying fruit flies and using them to understand important questions for over 100 years. And so genetically, we know a lot about them. They're very well characterized. They also, because they're so small, in a small area, when you do a spaceflight experiment, you can get a lot, you can fly a lot of these little fruit flies. And so when you get the data back, you have a lot of information, a lot of samples to do your studies. Another thing that I think surprises a lot of people, but is important to know, is that fruit flies actually are when you look at their DNA and you compare it with DNA, say, of humans, there's a lot of similarity. So when you look at the database, which has the collection of genes which are important for human function, so when you get any kind of an anomaly, then you can show human disease. When you look at that collection and you compare it against the fruit fly DNA, you actually find more than 70% similarity. Wow. So more than 70% of those genes are similar. So there's a lot that you can use the fly to do studies with, and then a lot you can understand about other more complex systems like the human being and how an astronaut would experience spaceflight.
We study the behavior of colloidal samples. What does that mean? Colloid is fluid that has particles in it that we may not see. Everyday products are colloidal, like toothpaste, shaving cream, detergent, milk is even colloid. And the researchers want to find ways to extend the shelf life of some products, and also understand the behavior of the particles inside these products, and probably for many of them improve the manufacturing of those products.
One of the things that we discovered in the FLEX experiments is the so-called cool flame combustion. What happens there is the hot flame goes out, and then the droplet continues to burn at a very vigorous rate, but without any visible flame. So this has got practical applications in the form of using liquid fuels in an efficient and a clean way. And the space applications for this is also very critical, because from the point of view of fire safety. So if you have a firefighting strategy in a microgravity environment or a spacecraft environment, so if you think once the hot flame is gone, then you can't think that the fire is extinguished. What is happening, it's almost like smoldering combustion on Earth. Like if you put a piece of log in the fireplace and the flame goes out, but it can still smolder and produce toxic gases. Just like that, this is the first time anybody has observed this. Hot flame goes out and there is no visible flame, and still the liquid fuel continues to burn, partially oxidizing this fuel, spewing out combustible mixtures. So it is very important to know that. So that in principle, at least we have demonstrated that after hot flame, the cool flame can be a fire hazard, because it can reignite and then bring back the hot flame.
I never tire of those amazing images. But that's not all that happened on Space Station this year. There were laser beams, 3D printing, and even a bedtime story from space. And let's not forget those ever-important human research investigations.
We're looking at the immunosuppression in astronauts. We're using very complicated bioinformatics in order to look at all 30,000 genes involved. And from there, we are finding the way to modulate the immune system, not only for people in space flight, but also for people on the ground. For instance, older people, as they age, they have an immunosuppression. Something like 70% of the people in ICU that die have had pneumonia. We're also looking at ways to modulate the immune system for autoimmune disease. That would be when it's turned on too high. So the hope for our research is that we're going to be able to pinpoint the target areas that might make a good pharmaceutical target. My experiment, the first one flew on station some time ago. We published the paper 2012 about the experiment, and this is the next experiment following.
So what did you find in the first study?
In the first study, we found some of the very early signaling events that change in the immune system in microgravity. With this study, we're carrying it one step further. We're able to look at microRNA, where we will be able to have brand new pharmaceutical targets.
We hadn't had any data that allowed us to show specifically how there were changes. We just knew there probably were. So this was the first activity that we did a formal evaluation of how people run and compared running styles in normal gravity to running styles up on the space station. We learned a lot of really cool things. First of all, from an exercise perspective, we found out that running fast is really, really important. The faster you run, the greater the force is between the foot and the ground. From a brain perspective, and this is where people who study motor control and how the brain works, and maybe people who are interested in studying how the brain might change due to injury or due to aging or these sort of things, what this means is that gravity is not necessary for someone to run the same way that they would run on the ground. So the data tell us that when it comes to running, people can pretty much do this automatically, even though that input is different from on the ground. And there hasn't been any other studies that have been able to study a real large-scale multi-joint movement like running, where you take away gravity to see what the effects are. So this is one of the first that's been able to do that. It was kind of a serendipitous finding. Our purpose was to understand exercise, but we also found out a little bit about how the body controls running.
The printer has two windows, and we're placing the MSG cameras very closely to those windows so we can monitor the actual extrusion process as the prints and the layers are being deposited. We'll be able to see that in detail. The real objective of this first phase of the technology demonstration is just to verify that the process works in microgravity the same way it does on the ground. NASA and Made in Space have flown parabolic flights and tested this, but you only get the short spurts of microgravity. So being able to test this on space station and print complete parts in microgravity, as you mentioned, space station is actually the only platform where we're able to test this technology before we use it in further out exploration missions. The first phase is really focused around those engineering samples that we'll be studying, but then the second phase, once we see that the process works in microgravity the same way, we'll turn its focus more toward the parts that we print and demonstrating their utilization on space station. So this is actually truly a historical moment. Since the inception of the human space program, we have been completely dependent on launching every single thing we need from Earth to space. So it's a very constrained supply and demand chain. For exploration missions, you mentioned earlier, that's just not plausible, it's not feasible. So I think we're making history by, for the first time ever, being able to make what we need when we need it in space. And even though it may sound a little like science fiction, we're actually able to email our hardware to space instead of launching it.
So what we're trying to do is transmit data over a laser beam, which is very focused, as opposed to a radio frequency beam, which is diverges quite a bit over time. And because we have a focused laser beam, we can get a lot of data to the ground. So with higher data rates, we can get data moving faster, and we get things like high definition video across that data stream. It's very important for going out and exploring and getting our science data back to the ground. The ISS gives us a platform that's already existing. It's an existing infrastructure. You can think of infrastructure used today like using Windows on a PC. That's a platform. The ISS is a platform, and that gives us a window really to look down at the Earth and to demonstrate and really use this optical link as a test bed, as if we're in the laboratory. It rotates over the Earth just like a orbiter would rotate over Mars, and we can test things out like what if a Mars rover were to communicate with an orbiter in space? We can test that out by communicating between the ISS in Earth orbit and a ground station on the Earth, and test out those technologies. We have been tracking the space station with our telescope at Table Mountain. What we do is we get a GPS state from a GPS, same way you get it on your iPhone, and we use that to predict where the ISS is going to be in the sky from our telescope. And so we've tracked the ISS on our telescope overhead early in the morning when it's dark on the ground, but the ISS is lit up by the sun, so we can actually see the ISS passing through our telescope, which is pretty neat to see. So the next time we'll do this, we'll see a laser pointing back down at us, sending data down to the ground. It'll be very exciting.
We have right now 13 schools that participated last year, flew on the zero gravity plane out of Ellington Field, and of them, one school was selected this year and 2 in previous years to go to the International Space Station. However, none have reached that spot yet. All 3 schools are working on it, but we have yet to send one to the ISS.
But it's a learning process, right? The whole thing, the procedures, working with NASA, it's all a learning experience for these kids.
It's a huge learning experience, and the schools that who have been selected have actually been working for 2 of them for 5 years. So every year they fly on the zero gravity plane, they improve their experiment.
I'm astronaut Alvin Drew aboard the Space Shuttle Discovery. I'd like to read you a bedtime story. This one is called Max Goes to the Moon by Jeffrey Bennett, illustrated by Alan Okamoto.
A really cool moment for you, though, was when an astronaut read your book from space, right?
That was a pretty incredible moment when I got the phone call from Patricia Tribe saying that Alvin Drew would like to read one of my books from space. I didn't believe it was a real phone call, and once I finally accepted that it was, I sent them the PDF in that case, and astronaut Drew read the book from the final mission of the Space Shuttle Discovery, and that's posted up on YouTube.
The thing about the book is it's not just a children's book. I mean, the basic story itself is meant so that children 2, 3, or 4 years old can enjoy the story and see the great pictures. But on the side there are these things called Big Kid Science, where they go into all the actual physics and things like that. So if you're like me, when I used to have my favorite kids books I grew up with, but you're 12 or 13, you don't want to pull those books back off the shelf because even though you might still like the pictures and everything else. So now you've got an excuse to pull the book off the shelf and go, I'm reading up on the science here, Ma. That's why I've got the book back off. So even now it's got good science in it, and I like pulling it down off the shelf and pretending that I'm getting science out of it too.
Hi, I'm NASA astronaut Mike Hopkins on board the International Space Station, and it's one of my favorite times. It's story time from space.
Hi, I am JAXA astronaut Koichi Wakata. Welcome to Story Time from Space.
Well, after astronaut Drew read Max Goes to the Moon from the Discovery, that was sort of a pilot project, and Patricia Tribe went out with the demo tape and polled a lot of teachers and looked into it, and people were really excited about the idea, and then CASIS got excited about the idea as well, and they decided they would take all 5 of my children's books up to the station to be read from the cupola up there. So it's the 4 Max books and a 5th one I have called The Wizard Who Saved the World, which also has a little bit of space in it.
Oh, I love that. Now let's hear from NASA's Associate Administrator for Human Exploration and Operations, William Gerstenmaier, about what's to come on the International Space Station.
One of the crews carried a little, on their lapel pins or badges, they said off the Earth, for the Earth. And I think that's what really station is doing. The work we're doing in space, its ultimate benefit is to us here on the Earth. So, from the areas of the colloidals that we talked about earlier, and then some of the combustion research, all these things have very exciting applications to folks here every day on Earth.
We're looking into the future as well. I mean, we hope a lot more years on space station. So what does that look like to you?
Yeah, it's exciting. The station's been extended to 2024, and I think that's really important to this research community, that they see now a much longer horizon to go do their research and to really see the fruits of what they do come about. You know, when we were thinking just 2020, that's a pretty short horizon. By the time you build your experiment, you fly it, and then you get a chance to see if it works or doesn't work, that's pretty short. But when you think you've got all the way to 2024, you can get some real results and move forward. So, you know, hopefully the International Space Station is used to spawn other space stations. Hopefully this space station is kind of the innovation incubator that gives folks new ideas on how to do research in space, and it actually builds a larger commercial market for low Earth orbit research. And then the last thing I would add is we talked a little bit about human exploration beyond space station and what the role is space station has in Mars and Moon and other activities, and you could see space station playing a critical role even in those areas. So as we are addressing the human health problems needed for adaptation to long duration space flight, you could see how this space station is really that first step and that first real step in exploration. So as we push human presence into the solar system and we do this thing we call pioneering, space station is going to play that pivotal role. So it's neat to see station. It's neat to see it in this venue where we get a chance to see not only the typical NASA research, we get to see the commercial activity, and we get to see how station fits in the exploration role moving forward.
Finally, while it may not have had the biggest impact on scientific research this year, astronauts having a little fun with water surface tension in space certainly made a big splash on the internet. Earlier this year, some of the crew grew a softball-sized ball of water floating in space and nudged a compact video camera encased in a waterproof housing into the middle of it. They also broke out the station's 3D camera to record the exercise. When they sent the images back home, our television crew edited the footage and posted both a 3D version and a regular version to the agency's YouTube channel. In a little over 2 months, this video received more than 2 million views. By the way, that 3D video camera on station is part of a legitimate scientific investigation run here at the Marshall Center, studying why a 3D video camera in orbit does not degrade as fast as a traditional video camera. Right now, regular cameras are replaced every 8 to 12 months due to the high number of hot or burned out pixels, those little white dots you see in some footage from station. A 3D camera has virtually 0 burned out pixels, meaning it can be used a lot longer and save on the cost of sending up replacement cameras. The team here, led by Rodney Grubbs, is looking into the phenomenon and at the same time helping bring back some incredible images of our astronauts living and working in space. And that'll do it for our look back at the year in research on the International Space Station. Be sure to visit nasa.gov/station and follow us on social media to learn more about these and other investigations as we continue to work off the Earth for the Earth.